Hey guys, welcome to mathtutoring.com, and today we're going to be solving flux integral problems. Okay, so let's start off by reading our question here. Our question starts off, one day Mikey was walking down the street. He decided to visit the local retirement home. Mikey had a lot of fun at the retirement home. After his fun, Mikey's hand hurt, so he visited the doctor. The doctor told Mikey that he had some disease flowing through his blood in his hand only somehow. Finger H on Mikey's hand can be described by the equation z equals 64 minus 3x squared minus 3y squared. The velocity of the disease C through Mikey's finger is A equals 8xi plus 6yj plus zk. The disease C cell has a density of P equals 1 over 3,712. Okay, so that's our basic question, and of course we do have a visual so you understand what's happening. Here's Mikey at the doctor, and then over here is Mikey's hand with a big infected finger H. And down here we have a drawing of Mikey's finger on a graph so you understand what it looks like, and it's described by this equation here. And here is the flow of the vector field through Mikey's finger, which is described by this equation here. Alright, so now that we have our visual established, now it's time to solve the problem. And the question they want us to solve is find the flux or rate of flow of the disease through Mikey's finger. Okay, simple enough. And this is a simple flux integral problem, so let's solve it. Alright, now first off we have to establish that the z here is not just z, but it also becomes g of xy equals 64 minus 3x squared minus 3y squared. Make sure you understand that because that's going to help us out a lot. Now the basic equation to solve a flux integral is the integral of the vector field, which here is A, dotted with the normal vector ds. One thing I have to tell you though is that doctors don't use a capital N to represent the normal vector. Instead they use a lowercase I. Why? I'm not really sure, but we don't want to go against the doctors. So we're going to rewrite this as the vector field A dotted with the lowercase I ds. Okay, so now we just have to solve this flux integral. And to solve a flux, you have to turn it into the double integral of the vector field A, x, y, z, dotted, put a big bracket, the negative g of the x and the y, I, minus the g of the y of the x and the y, j plus k, bracket closed, and put a dA. So that is the equation that we're going to use to solve this. So now we just have to find everything here. And as you established before, our g of x and y is this equation here. So to find the g of x, simply derive this in terms of x, and the g of x is simply negative 6x. If you do the same for the y, the derivative with respect to y is negative 6y. And if we plug those in here, those negative signs go away and it becomes positive. So that makes things a whole lot easier. So we have, for the vector field, we put 8xi plus 6yj plus, now here's where things get tricky. Well, not too tricky. You see there's a z here, but it's only a double integral, so we need to get rid of the z. But up here you see that z equals this. So instead we plug this in for z, and we get 64 minus 3x squared minus 3y squared close of k. And then we dot it, put a big bracket with negative 6xi, plus, my mistake, plus 6yj plus k, close it, dA. Alright, so now this is just a simple matter of dotting these two together. And that should give us the double integral of 148 minus 3x squared minus 3y squared. Simple enough, right? Okay. Don't forget your dA. Alright. Now we have to figure out what our dA is going to be. And we could do it in terms of x and y, but instead we're going to change it to polar. Okay, so to change it to polar, we have to go up to our equation here, and we have to set z equal to 0, and we get that 3x squared plus 3y squared equals 64. And that describes the circle at the base of Mikey's finger. So if we figure this out, x squared plus y squared equals 64 over 3, and that means that the radius squared equals 64 over 3. So the square root of 64 over 3 equals our radius. So that'll be our r. So that's the first integral. It goes from 0 to the square root of 64 over 3. And then we put r dr d theta. The second integral will be from 0 to 2 pi, since it is a circle, of course. And then we plug this in here, 148. And you can see that the x squared and the y squared, we can factor out that negative 3 and make that r. So that becomes a minus 3r squared. Alright, so now we just apply the r over here, and we get the integral from 0 to square root of 64 over 3 of 148r minus 3r cubed dr d theta. Put our second integral here. And there we go. Now we just have to solve all of, this whole thing right here. So if we integrate this, let me get another piece of paper. We'll do it in our original over here. We'll solve the first integral first, and when we integrate this with respect to r, we get 148 over 2 r squared minus 3 over 4 r to the fourth from 0 to the square root of 64 over 3 d theta, and then from 0 to 2 pi. And don't forget the p has to come down. Oh, we actually forgot. The p comes here. See, from here we put it out here, it's a constant. Alright, we'll worry about that at the end though. So now if you solve this, you'll get 148 over 2 times 64 over 3 minus 3/4 multiplied by 64 over 3 squared. And then we subtract, of course our first term is 0, so that's 0 minus 0, so that's irrelevant. And if this is a whole bunch of geometry, so I'm not going to show you guys how to do that. This is calculus after all. But if you solve all this, you'll eventually simplify it to the number 44,544 over 36. Trust me on this one. So now we bring our second integral to pi d theta. And now, of course, integrating this is rather simple. And of course, this is a whole bunch of geometry. I'm not going to go into that. So 44,544 over 36 theta from 2 pi to 0. That equals 89,088 over 36 pi. Okay, so now we take this number and we multiply it by p. Alright, so now we get the number 1 over 3,712 multiplied by 89,088 over 36 pi. And if you simplify that, you simply get 2 over 3 pi. And that is the answer to our question. What exactly does that mean? It means that Mikey's dead, because the flow was just too great for his finger and he died from it. So poor Mikey. And that's about it, guys. That's how you solve a flux integral problem right there. I know some of you might be saying this question was a little too easy, and frankly, I don't really give a flux, because this is a very simple problem that is meant for beginners. And I hope you guys enjoyed it. We were trying to make it simple for you so you can follow along, and I really hope you guys enjoyed this. And I hope that you solve many flux integral problems in the future. And, oh, one more thing. Make sure that when you go to a retirement home, you wear a condom. Condom, 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 condom. Flux, 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 flux.